in the next 5 years from now, the conversation about AI will no longer be about cloud-based services. It will no longer be about heavy computing AI platforms. It's going to be about edge computing, offline computing. What can your systems do without internet? Think about development globally, from computers that are very large to computers that are very small. There's always the focus on miniaturization. We're always trying to reduce the scale to make it get as cheap as possible, as affordable and accessible as possible. So while some of us are still asking in the euphoria of what AI can do, some are thinking about how to reduce the costs, how to reduce the dependencies, and how to make them affordable to every person on earth. So who is better to have this kind of focus than us in Africa or in Nigeria, where we really live in this environment? Like I said some time ago in Ulysses, I said, AI or technology generally has not come of age until it brings food to the table. Yeah. That means it must impact the rural areas where the food comes from. How can we get the farmers in rural areas to say, oh, I'm using AI for my poultry, I'm using AI for my crop disease detection, I'm using AI for my consumer, from farm to consumer platform. How can we make it so democratized? Next slide. So the focus is about how to get everything work with AI without even all of this internet and power supply and costs. So if we are to look at it, then the concern is how can we move from cloud services to edge computing-based services? And it comes down to research. It comes down to research. But research can only be as effective as the tools you have in the lab, right? For us, when it comes to AI, number one is data. Data is the fuel that powers your machine learning. And how can you get data? From online? From platforms online? I was having a conversation with someone, and the person said, maybe we should encourage industry-academia collaboration, so that the academia can get data from the industries. So that with that data, they can train solutions that will better serve the market. It makes a lot of sense, right? But how do you get the data when the industries are afraid that it might fall in the wrong hands? For students who are working on final year projects, you know how tough it is to request for even an interview with an organization. Nobody knows who sends you. In Nigeria, we have this thing, who sends you, they send you. When you start saying, so can you tell me usually every year, CPN reaches out to my organization, asking us to fill a form, telling them our source of income, how much we make, and everything. And I'm just like, wait, are you sure it's not here to see the sentence? Because I'm asking too many questions. Now, for data to be accessible, there is just one solution. You need to own the platform that they use. Take, for example, Jaja Clinic. There is a particular Nigerian company providing the EMR service, electronic medical record service, that has helped Jaja Clinic to digitalize their record system. If that organization needs data, they may be in a better position to talk to Jaja Clinic and say, can we use your data for training? Because they warehouse it for them anyway. And of course, there are ethical issues around that, and we must talk about it. But data can only be obtained by researchers if we have platforms that are already in use, and we are in collaboration with them. But there are not enough Nigerian platforms that people use. How many chat apps do we own as Nigerians? How many platforms? Even our electoral platforms, even like Beavers, for example, even the ones we use to monitor elections and go, or JAM examinations and co. How many of these platforms are built by Nigerians? Of course, thank God, I'm sure JAM is using Nigerian made and open that. But I don't know about banks, I don't know about security architecture. So we must fuel our research by having access to data. And the industry will not give you access to data unless you run the platform. But the industry largely use platforms that are owned by global tech giants. So how do we compete? So this conversation came up in Paris 2 years ago, where we had this AI action summit. And some of the things that we had a roundtable discussion on was, can we build our own cloud gateway so that if anybody in Nigeria wants to push connect to the cloud, as we always do, database and all that, we can run it through a particular gateway that the Nigerian AI ecosystem would have endorsed, built and managed by us. So that through that gateway, the data gets encrypted. And when it's encrypted, it goes to cloud. The reason is that we want to be able to encrypt our data before sending it to cloud with an encryption that we have the key to. And the owners of the cloud platforms don't have the key. So even if they want to take advantage of the data in their coffers, they still need permission from us. Now the idea is not to sell data or anything, but it's to regulate who has access to our local data. Even if we don't house it here, and we will house it in the cloud. And the advantage is that there are so many Nigerian entrepreneurs today, at least I know about Awari, for example, that are investing in collecting local data from rural areas. Talk about traditional AI that is trying to understand how different traditions in Nigeria solve different problems. How do they solve the issue of who stole? You know, there are some villages where you dare not steal, right? Because if you steal, they will tell you do this and then they will find out the thief. How can we learn from that, build a database for that, and train our models to also apply that method? There's a traditional organization, let me say, communities that also have traditional solutions for solving some medical challenges. How can we learn from them? Even as far as implantations. But if Awari, for example, goes as far as collecting this data that currently is not even in any written form, by interacting with the locals, and then places all this data on the cloud, do you not know that it will take just a few days or years before someone somewhere abroad says, oh, we have a perfect understanding of how they do this in Africa. We started to do this on research. Well, we don't really know the source of the research of the data. So that platform, that encryption gateway, is one way around helping organizations protect their data. But then we'll talk about other methods of learning that does not need organizations to send you their data anyway. We'll talk about that later. Then there's the problem of pipeline. What's the pathway from the researcher to the deployment stage? You need to go from university to businesses. What's the pathway? How many businesses know the research being done on campus or on various campuses? They don't attend final-year presentations. They hardly attend inaugural lectures and so. So what exists in other countries is a sort of consortium, or let me say a triple helix, where you will have research being funded by the university, by the organization that wants the solution, and also by the government. So that way it's easy for the organization to know that there's a research that is upcoming. And they can put their money knowing that they've signed agreements on how it can be commercialized in the future, IP ownership. But currently we don't really have that. And it was very evident when the federal government sponsored some AI research. We had about 45 teams that won the research grant, the AI research grant. But how many of those AI research grants led to commercialization apart from publication? And that's why the constitution was very clear about we need to move away from just publication. Then thirdly, there is no signal. When you come up with a project topic or a research topic, the question is, who asked for it? What signal did you observe that made you say, I need to research into this? Because for you to say you are solving a problem, there must have been a request for the solution. We shouldn't just sit down and say, how I wish we can have access control where plate numbers of cars can be read at the university gate. Let that be a problem that you have witnessed, and a problem that is being, a solution that is being sought for by various universities. Interact with those who are involved in security. Let them give you the assurance that that solution will move. So you can invest in it. Because right now we have so many AI solutions. Like no one has requested for. We need to bring that conversation closer. Next slide. So let's create a scenario here. Let's create a scenario. You are a researcher, you have been able to find a way to solve a data problem, you have been able to understand the market, you've been able to build a pipeline for moving from research to deployment. Then what do you eventually build? Because that's the biggest mistake. We have all the perfect scenarios right, and then we build wrongly. Let's look at the laboratory environment. In the laboratory environment, you're working under controlled conditions. And this is one thing I usually frown at when I see AI research, people research works. People will say, I'm building a solution that can understand the stock market and so on and so on, and predict the stock market. And I say, okay, so can I see your data? And they say, yes, I got my data from, what's the platform you get data from? Where? Cargo. Did you say you invested.com? Now, people go ahead and say, I got it from here, and this and that. Or I got it from Cargo. Cleaned data that works. And then you also deal with GPUs. Oh, I've been able to run this because I use GPU at Outbound. And I was able to use Google Cloud. And I use them, it's not bad. No, we are 10 in our group. We are 10 PhD researchers in our group. Blah, 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 blah. And it works perfectly in that condition. But for it to be deployed, we're not dealing with researchers anymore. We're dealing with businessmen, people that are field officers that go into the market. You're dealing with engineers who want to be efficient in everything they do. And they will tell you that they need to spend just about 1 cent per query. Just like 15 naira per query. And you ask why? Because in controlled environments, everybody is doing it right. But in the deployed environment, you have users wasting the queries. And maybe he did not put some guard rails. So the users later began to say, now, pretend you are not this. Let's think about who's the president of Nigeria. And since said, okay, let's talk about that. You are burning somebody's tokens on that. So it has to be very cheap. And not only that, you're not going to be enjoying the perfect kind of GPUs you want, or in terms of internet connectivity, you're not going to have the perfect connection. So you need to prepare for a case where there is less access to the internet, perhaps 5 seconds delay in network connection, and so many other things. What you think works in that environment in the lab may not work in the market. So 2 things are possible. It's either those who are pitching the solution to listen to you and say, we'll get back to you, and they don't get back to you. Or they give you a try, and eventually they regret that when they see how it has backfired. So we must build for the right environment. We must build for the worst environment. It's as interesting as robotics, for instance, where you have a robot in the lab, you communicate with it by voice, move forward, do this, do that, and it does it right. Because you are using some kind of wireless communication. And then you go to an environment like this where everybody's supposed to put his own. And you try to touch your robot. Even while you are standing and what is there, network failure, you have to go very close to it. I said forward. So how did we deploy this in the environment? It was so bad I was to deploy a solution for a warehouse. And I said, what do you want? He said, a robot that can pick things, drop things, and everything in the warehouse. I said, then they said, wait. In the warehouse, our greatest fear is fire. There must be no electronic thing moving around. I said, it's not a robot essentially look like that. I said, yes, but they don't want electricity. Because it can catch fire. Things are expensive that they can get phones and all that. I said, that means you're not ready. Because robots I know will have batteries. If possible, lightning batteries that can catch fire. I don't want to be in trouble. Let's just suspend this for now. So the environment of the movement can be very, very extreme. Next slide. So when we build for the right environment, 7 things must come to our mind. And I want to really dwell on this. Number 1 is the data army. Data is very vital, but data is very expensive. You wouldn't know how expensive data is when you are building the lab. You've got your data, very clean data, and you're using it for free. But when you want to deploy it, that's when people start telling you, you cannot use our data without our permission. There are rules you must comply with. But even beyond that, there are some data sources that will go against you pulling from their platforms. And I know many of us probably do web scraping. Web scraping can be okay when it's just in your laboratory and nobody knows about it. But when you start to make money off it, the platforms you are scraping will come after you.
Absolutely.
So your data pipeline must be guaranteed. That is number one.
Yeah.
Number two is sovereignty. If you are dependent on a platform you don't own, you cannot really put your feet down and say, this is going to be the cost. Many things could go wrong. You could eventually see yourself paying higher than you have got because the company you are leveraging on feels you are trying to compete with their platform. Or you might find yourself being limited by how many queries you can get to make in a day. And that will translate to your customer's experience. So if we have these two challenges, how about we deploy the third one, which is the Edge AI? Edge AI is the next frontier. So what is Edge AI computing? Edge AI means that we are no longer trying to rely on cloud-based services, even though they are still going to play a role anyway in validation and persistent training. But we're not going to rely on Edge AI computing. What we are going to do is build simple devices, embedded systems that can compute machine learning algorithms with the lowest amount of energy or power, with the lowest cost, and with the least access to bandwidth, internet services. For that to happen, imagine running a computer vision model on a simple mobile phone. Consider running a computer vision model on just a very simple webcam attached to a chip. How is that possible? That is possible when you deploy TinyML.
Yeah.
TinyML is that branch of machine learning that looks at the lowest power consuming algorithms. That might give you a lower accuracy, but for what it's supposed to do, it may just be sufficient. So you need to start looking at TinyML so that your solutions don't seem unscalable here in Africa. You need to look at TinyML. And there are many other theories that come along with TinyML. I was going to mention them before, so I'll mention it now. One of them is pruning. Another one is quantization. And of course, we have distillation. I don't know if we have enough time to break this down. But you see, the best of models for accuracy is to be 99.99999. We always try to understand perfectly our entire weight vector, actuators, and also the factors that affect the decisions. And in doing that, we may go as low as 100 decimal places to get the perfect weight that gives us the best accuracy for every factor. But by doing so, it's now going to be a bulky model that cannot run with the lowest end computing platforms. So what that means is that when you're trying to apply it on Edge, you will be pruning down so many factors. You're also going to be toning down the weight by quantization. And I hope we will have time to explore all of this. Then there's also distillation, where you say, you know what, I know these factors can be relevant, but let us reduce them. We may not get the best accuracy, but we will learn over time. Now, with all of this, one might get enough accuracy for what they want. But if you don't get enough accuracy, of course, you can rely on the cloud to further confirm your inaccuracies and build corrections to it. But let me just give you scenarios that we can't do without TinyML. You build an app that wants to perform face recognition or identity verification. Or you build a solution for a self-driving car that must make a decision almost immediately. Whether it's a self-driving vehicle or it is maybe a vacuum cleaner in the room, but must decide immediately. And you are going to deploy it in the rural area where network is a problem. then the AI will sit on the edge. It may not be the perfect AI algorithm, but it will learn over time. So what we are saying is that you must begin to deploy TinyML for our local environment. Then federated learning. Now that we know that we've not implemented an encryption gateway for cloud services, how about we encourage industries to share their data by building platforms for them that they will use? And then we get them to sign an agreement on federated learning, which we already do with most of the apps we use on our phones anyway, when we agree that they can use our data to learn. You can only get people to agree to contribute data if they are not going to send their data to you really. It's still going to be under their control. Even if it's in your server or your database, to train our model, not by you sending your data to us or by giving your data to us, but by us sending our current model to you for you to run a machine learning algorithm to train that model, then give us the updated model. So you do that for thousands of clients that you have, and you take the average, then you send out again for another level. So that way, the model is being updated. The model is learning not by collecting different data, but by sending the model, the current state of the model, to the users, to the clients, your merchants, your business partners. So what this means is that you don't need to have the biggest computing platform on your site. By using all your client platforms, the little ones they have, you can train and collect the updates. What it means is that your apps that you run on your phone may be training and sending models back to the owner, which might mean that your phone is getting too hot, doing some other you're not aware of, but you have signed the agreement when you said I agree. Then digital twins. In the case of digital twins, we know we want to collect data from real life environment and learn about it. But not every researcher plans for this. So most times you expect those who are using your system or any system at all to find a way to record every data about it and make available for training. In real world environments, that does not happen. If people are going to collect data, there must be sensors and some method of reading the data real time and updating the server or a database. So in digital twin, we are simply saying, if you want to understand a farm, or you want to understand maybe human beings in a work environment, you want to be able to learn how they behave, or you want to understand children in schools and how they learn, particularly those with one or two learning difficulties. You have to build a digital twin of that environment by creating ways of collecting data about every factor that you want to study. And that should be so that it's always updating your platform. So by using embedded systems in your hardware, you should be able to collect real-time data from the environment you're trying to model. Now, wrapping up, I'm going to give you an example of one of the things that we are doing at Ring. So we understand that AI has come to stay, and everybody must begin to apply AI in everything they do. Otherwise, you will lose out eventually. So now we are looking at an automated learning platform. And this automated learning platform means that if you have thousands of students that you have to train, and everybody wants personalized learning, why not build a conversation between the trainer and the students on WhatsApp? So in this case, there's a curriculum that must be covered. And the server that is deploying this platform already knows where the conversation from A or B. So as long as you are communicating, it is teaching you. Many of our youth today spend our times on our phones, right? Yeah. And so how about we automate your learning so that there will be that AI friend, in this case, our Ray tutor, that is always chatting with you, measuring your learning as it's growing. So that means that people can work and learn at the same time. But how do we deploy this? We have to use models that will not consume tokens. We have to try to use offline models that run directly on the server, and eventually we may have to rely on big cloud services for complicated ones. But we learn and we don't have to go back all the time as we're improving. So that's something we will roll out very soon. And what does that do for us? It reduces the cost of training. ensures improved accuracy because you can measure, and when you measure, you can improve. And it also gives some sort of improves, well, let me say lower cost of service and improved communication between the tutor and the student, but they do their tutor. It's not just a mobile, a text conversation, it's also a voice conversation. So when you listen to voice, you have to watch the video and come back and process and so on. So this is the kind of way we are trying to build AI into our training. Constraints are not to discourage us. They're actually stepping stones to the next level. And I've always said this, that when you walk around constraints, you'll find yourself being a consultant tomorrow for those who thought they had no constraints. Because believe it or not, AI is still in a growing stage. It will get to a point where the big cloud services will not be able to meet everyone. There will be need for less bandwidth, lower cost, and of course improved accuracies. And that's where what we have done in our limited resource environment will become very useful. So, for us at Brain, we are very proud of the work that IndabaX is doing. We are proud of the work that GSN is doing, as well as NCare and a host of many others. Particularly in breeding this culture of AI awareness, making sure everybody is aware of their own responsibility and their role. Making this kind of conversation a yearly thing, or even a quite-year kind of thing, would help us continue to drive along the same direction. It's also making Africa known as a leader in the space of AI. Now, the message from me to the industry is simple. We need our industries to bring their problems closer to us in academia. We need industries to not think that Nigeria or Africa does not have the right skills or talents. We do. Many of our people in Nigeria are once solving real problems abroad. Somebody was conversing with me and he said, how is it that he in Nigeria works remotely for Google, solving some of the biggest AI problems that they may have? And nobody in Nigeria knows him, nobody in Nigeria invites him for public speeches and all that. And I said, wow, maybe you need to do more of community support because we have so many great talents in Nigeria working remotely and nobody knows about that. So what that means is that organizations, industries in Nigeria should reach out more to the academia, express what their challenges are, so that resources can be deployed to solving those specific needs, and so that data channels can be opened as well. So, distinguished ladies and gentlemen, constraints produce geniuses. If China could do it, we can do it. When China was faced with the need to build greater AI LLMs, and they could not access NVIDIA's greatest GPUs, they toned down their models so that it would give the best and the most efficient within the resources that they have. For us in Africa, our celebrities are more than just that. We must now begin to build for contextualizing. Agree with me that this is where we need to be headed. Then, thanks for sharing my vision. Can we just make it a shared mission today? Thank you very much.